Hey folks, welcome out there. Hey, it is Mathline time. You're the right place. Afternoon, absolutely. Wherever you might be, glad you're tuned in, all right? Hey, what do we do here? We love to do math, right? And we need you to call 844-686-2378. That will take care of us getting a great little question and answer going here. And by the way, I'm Ernie Roberts, and I am your host for Mathline this afternoon. We are so glad you tuned in, and now what we're going to do is get this thing rocking and rolling. I want to take us out to our phone operators. We got 3 young ladies from Bearden today. They're awesome. It's awesome to have them here today. And there we are. Hey, that is Owie, Sarah, and Braden. All of them have been here before. All of them love to come back and take calls from our viewers. We want to do that today, all right? Give them a reason for giving some community service today, all right? And give them that call, that number 844-686-2378, and life will be good, all right? And hey, I love to talk to you guys too because it makes the show rock. So give us some calls, let's hear some voices, and right now, let's take out problem of the day. And there we go. Last year, Nemo, I like that name, Nemo. Oh yeah, it was a great show, Finding Nemo, great movie. Sold $320 of fruit for band. Oh, I've been there and done that. And $360 of fruit this year. Wow. All right, so last year and this year, Nemo doing a good job there actually. It's pretty good. What is his percent of increase in sales for this year? Okay, that number, oh my goodness, wow. Well, we first of all have a couple of things to look at here. We got Nemo selling fruit last year and this year, and it's talking about a percent of increase. Well, he certainly did. He went up, looks like $40. So that's the important moment that we've got to work with. So let's take a look at this problem, play it out. And again, last year versus this year, we want to see what happened. So I'm going to start him off with, you know me, I like this little part over base, and we're going to get it to percent over 100. And the whole idea is, what is the percent of increase? So we're looking for this percent symbol right here. That's where we're going on this thing. Now, not to be outdone, all right, what's the part? Is it $320 or is it going to be the $40? Well, some of you say, well, Ernie, can you do it both ways? Yes, we can. But we've got to interpret what that final answer is going to be when we do it the other way, all right? So you said, what do you mean the other way? I'm going to go for what I think is straightforward. Let's put his increase right there. That's where we ended up. We had $40. Where did he start? Oh, you're going to ask me. That's a good question. He started at 320. That's what we're looking at. We're not taking it out of 360. We're going to take that over 320. Okay, so there we have it. Equaling, okay, how about it? Put a big N over 100 there, and we'll be ready to kick this thing out into the park, okay? Cross multiply. Man, we do this so much. Proportion. It's so easy. And this way we make sure we don't mess up on whether we multiply or divide. We want to make it real easy on you. When we cross multiply, you're going to take it on the diagonal. So 320, tapping into it. On the other side, let's add 2 zeros to that 40. So we'll be at 4,000. And looks like we're about to run out of space there, so we'll see what happens. We're going to divide both sides by 320. And in doing that, we're going to go to the calculator. I'm not one for mental math on this one. So let's go to the calculator and see what it's going to give us here, all right? We're taking 4,000, and we're going to divide by 320. By the way, we divided that 320 to both sides, and while it looks good on the left, it's kind of nasty looking on the right, but maybe it's not so bad. We're going to check it out and see. That's what calculators to help us out. Oh, that did come out nice, 12.5. By the way, that's our percent. So let's go back here and see what happened. We get rid of the 320s. Let's see, there we go, rid of them. There we go. And we are going to divide this thing out. We'll get an N equals 12.5. It is a percent, all right, at that point. We don't need to move the decimal 2 places again. We've already, that game is not going on here. This is actually what percent you're looking for. So you're getting 12.5. And I said there could be a possible thing. What if you had done this? And it's always a good one. What would have happened if you decided to use 360? Okay, if you'd use 360, I won't get too high here, out of the 320. And we said, how about it, n over 100? Now, I can already tell you, you can already tell, this is going to give you more than 100%. So what would you need to do? You would simply need to subtract, right? Subtract it off. Let's see what happens to see what we would have there, all right? So, in other words, we have to subtract 100% from the number. Let's see what happens here. I'm willing to bet, well, I'm not going to bet. Could get in trouble. And those young folks from Bearden High School, they might get me on that too. All right, let's see. Add 3 zeros. Let's go back to the calculator one more time and see what happens when we take 30, ooh, wow, that's a big one, 36,000. And we divide it by, how about it? We divide it by 320. And we do. We get 112.5, okay, or 112 and a half. So let's go back to our page here, and we're going to divide both sides here by 320. And what happens there, that goes away. We got n equals, and we said 112, and that's a percent also. But remember, we just want to know how much the increase was. So we were at 100%, went up 112.5%. That means we moved up 12.5. So the difference in this case is, this is for if we use 360, what we need to do here to find the true percent, we take our n into one more step, we got to subtract. See, we subtracted to begin with to get 40 over here. Over here, we've got to subtract now. So we will take that minus 100, and guess what? We still get 12.5%. Different way to solve the problem, but still interpreting in the final answer. So there you go, and that's where we start, okay? That's what we got going. Now, folks, it's time for you to get those phones ringing. We've got 3 operators here. They are having a good time, but we want to have an even better time, which means you guys call in and make the show rock. And we do some math problems here on the air. We're live. This is our last day this week to be live on the air, so we need to hear from you. Give us those calls. Once again, that number 844-686-2378. Don't want to miss out on these opportunities, so give us some calls, all right, out there. And in the meantime, like I said, we'll work some math problems, but I really would like to hear from you guys. What kind of problems have you got to take care of us today live on Mathline, okay? Now, yesterday, I left us again with a cliffhanger, which basically has been left as a cliffhanger for 2 days in a row now. So let's go ahead and see if we can get this thing out of the way, because it happened. My goodness, it happened. Everybody's going like, oh my goodness, it looks like a lot of things happened there. Kind of crazy, isn't it? So starting off with, had a call from Maryville. This was last Thursday, all right? Seems like it took a week to figure this one out, right? And basically, it looks kind of like that peace symbol there, doesn't it? You know, the old, with the circle and the good old things coming out of it there. But what it is, it's a circle, and this basically is a radius of 2, I think 2 units. We didn't get an actual measurement on it. And the idea was, we have an isosceles triangle out here that had 50, 50, and 80 for degree measures. They add up to 180, so it would be. That's the big one. So anyway, we're going to draw, because you know what? That's the advantage we have with an isosceles triangle. We could draw this whole long strip down through here. And now we've got a right triangle on the right side. We've got a right triangle, big one, on the left side. We've also got 2 little right triangles up here. This is where we started yesterday. We decided we were going to use this little triangle right here, and we were going to go for this x being our hypotenuse right there. So in order to do that, we have 2 and we have x. Everybody see that little right triangle? There we go. I'll keep curving it through there. Oh yeah, shape it, shape it. We've got 2 over x, because that's the way the sine works. Sine of 40. That's what we came up with here. Sine of 40 equals 2 over x. We cross multiply. Boy, we do a lot of stuff with proportions, don't we? That's why they're important, my friends. So some of you right now watching out there that may be in the 6th and 7th and 8th grade, you're going to see proportions right on through trig and right on into geometry and algebra 2, calculus, all those good things. They're very important, so don't forget them. Don't forget how to do them. Anyway, we went yesterday, and I'm going to go back to it on the calculator. Well, first of all, let's show you what happened here. We divided the 2 by the sine of 40 degrees. And let's go to the calculator where we did that. And I want to make sure we all understand one important thing here. When we go to the calculator, we've got to be sure that we are in what we call degree mode. We are, okay? You put that thing in radian mode, you're going to have a problem getting correct answers on this situation. This is all about degrees. All right, so make sure when you use one of these graphing calculators or scientific calculator, whatever, it says DEG somewhere, or you have the whole thing highlighted like we do here. We're in good shape. So let's clear that out, and let's go back to what we need to do problem-wise. We need to take 2, and we're going to divide it by the sine, and that's, by the way, that's what these little keys are, sine, cosine, and tangent. So pop it right there. We're doing 40 degrees, and we're going to put a big enter on that. I gave us yesterday a 3, we rounded to the nearest tenth, all right? So I gave us a 3 1/10 moment here, and let's see, we can go back to my paper now. There we are, 3 1/10. So that's this little stretch here. Now, dear friends, we have a 2, and then we went on up a little bit, 3 1/10. That gives me 5 1/10 for the big, nice right triangle here. And my thought is, all right, so let's put it over here. In fact, this is why we drew it out. So first of all, we went here to here, okay, used the 40. Then we looked at the long run here, which, by the way, that whole long run is 5 1/10. And we notice we have, with the 50-degree angle down here, we have a tangent going on here. You say, oh, Ernie, what's a tangent? Tangent means we take the opposite side over our adjacent side. We need to know, by the way, why do we want to know z? Because we're eventually want to know this whole long length here. So if we get this, we'll double it, and we're home free. Guess what we're going to do? We're going to cross multiply again, and we're about out of room on this thing, so we're going to almost leave it, but I want to go ahead and finish up. Tangent 50 times our z equals to, 5 1/10. Guess what? We got to divide again. So what's going to happen here, z is going to equal to 5 1/10 divided by tangent of 50. Let's hit that real quickly, and I understand we got a caller waiting. We'll get you here in just a second, all right? I want to finish this one out, and we'll put this thing to bed. If I can get to the 1. Divide it by, how about it, tangent 50. And kick that around. It looks like it's about 4 3/10. Since we're rounding off to the nearest tenth, we'll go with it right here, about 4 3/10. Some of you say, well, Ernie, that rambles on forever. It does, because trig functions are basically approximations. And that's the idea. Some of them come out perfectly exact, but they're few and far between, all right? Most of them ramble on and on and on. And by the way, we could do that 50.5 degrees. We have 50, goodness, 0.32, 33, all sorts of different things there. We could add decimals, but we're using 50 because that's what we were given, all right? So it looks like our z value is, we're going to go with about 4 3/10. And if you do that, that's what we got here, roughly. And actually, I'm going to go one more step back. I'm going to go 4 28/100, okay? Because that's close to 3. It is. And then this is also going to be, friends, this is also going to be 4 28/100. Just add those together, and you will have the BC value. And it looks like to me it's about 9 50s. No, it's not even. It's going to be 8 and 50. We don't have any carrying going on there. That one's really easy. So there you go. So it'll be about 8 and there. And to my caller who brought that up Thursday, thank you. That's a great problem. And I hope some of you going like, whoo, that pre-calculus stuff gets pretty busy. It does. It does. So again, that's what we're here for, to try to please everybody. And now we've got another caller waiting on it, and I'm glad to hear from those. Welcome to Mathline this afternoon. Who am I talking with?
Rachel.
Hello, Rachel. How are you doing?
Good. How are you?
Can't complain. It's a good Wednesday here, and good to talk with you. Where are you calling from, by the way?
Knox County.
Knox County. Great to have you with us this afternoon. And what kind of problem have you got for me?
A distance problem.
Oh, distance. All right. Are we hunting it down? Is it a coordinate problem then?
Yes.
Okay.
2 coordinates.
All right. Let me put this down here. Because there's also that thing called a rate times time equals distance. So I didn't know if we were, which way we were going. But this makes sense. So we're going to do the coordinates. So what have you got going for me?
The first point is 4, 2.
All right. Got a 4 and a 2.
And then the second point is -3, 15.
-3 and, woo, 15. Give me some big numbers there, aren't you? All right. Now, I'm going to say this. The whole idea behind the distance formula, it's really a version of the Pythagorean theorem. So if we were to plot this thing on a graph, we would be able to create a right triangle. And I might go back and do that here in just a second. But I bet you're wanting to use the distance formula, right, on this, since the numbers are pretty intense. All right, so, and it's also based on the Pythagorean theorem. Because what we're doing is we're picking up a big old woofing radical, and we're going to take the difference in our x's, which, by the way, is sort of like run when you talk about slope. You know that?
Mm-hmm.
And we're going to add the differences in our y's over here, which is like rise, but we're going to square them because that's what Pythagorean theorem says. A squared plus b squared equals c squared. And then to get to that, back to that c, or in this case, we're calling it d, we're going to just take a big old square root there in the end. So let me go ahead and finish the formula, okay? For those who are watching and may go on, what is he doing? We're going to take the x's, we're going to subtract them. That's easy. And we're going to take the y's and subtract them. Is that the formula we're talking about here?
Yes.
All right. Now, where in the world do we go from here? Well, I guess we do some substitutions. So you've set it up. I like kind of like a bunch of s's through here, except for one point. There's one a involved, but most of these things are all about parts of the s's. You just got to remember what to do first. So we've set it up. Our next step is going to be substitute. And let's do that. Keep the radical. It's not going away till the very, very end. But we're going to go inside here. We're going to say 4 minus, what is that, a negative 3 squared, because those are your x's. And on the other side of our coin here, we have 2 minus the 15, and we're going to square that. So far, so good?
Yes.
That part was easy, isn't it? We do have all the right numbers and everything there, right?
Mm-hmm.
So now here's where I want us to be careful. I always want people to be careful because I get concerned. But I just changed those to plus a positive, right? Because it's like two negatives jamming. So sometimes students forget that. And sometimes when they see a negative 3, they just say 4 minus 3, and they forget to put a negative 3 there. So I just want to make sure sometimes when you're working these, I just want to make sure that was not one of your mistakes or anything happening, okay? Now, that's 7. But what's going on here? This is 2 minus 15, which gives you what? Minus 13? We're going to square that. Now, I like for my students to be able to do a lot of the squaring in their head. And some of them will still go ahead and they'll type in negative 13 and hit a squared button on the calculator and not put a parenthesis around it. And when that happens, they get minus, what would it be, 169. And it's not what we want. A negative, folks, squared. We take the negative, then we square the negative 13, and it's going to give us this, well, we'll put it there, negative 13 squared, all right? So that's important. You've got to put those parentheses there if you're going to play on the calculator. Otherwise, you're going to say, oh, it's negative 169. Can't be. This is always going to be based on positive things, okay? So here we go. How about it? Let's do some mental work here. 49 plus how much? 169? Is that where we were hanging out?
Yes.
Let's see what our friend over here says that's going to be. It's not going to be pretty, you know that? It's not very pretty. It's a big radical, and I hope it'll simplify. We'll find out. Let's see. Woo! Out of 218. All right? So we have this thing, the square root of 218, which I got a funny feeling they may say, take it to the nearest or to the nearest hundredth or something on that. Any ideas what might divide into that evenly? Do we have anything that'll go? I know 4 isn't going to fly. Will 9 make it in there? I don't know. Does 9 divide? Because that's what we're worried about. Can we simplify it by square root? Some of you are going like, what is he doing? Let's see. Well, if he's going to put the right numbers in there first, so let's clear all that. Clear the whole thing. How about it? 218. I don't know if it'll divide by 9. It's not going to go by 4. I know that. Nope, didn't come out even there. Any ideas on that one? Is there any numbers that'll come out with it? Can we break it down any? I think that may be the best we get, because I want to take in other words, we've got to divide by perfect squares. And if divide by 4 doesn't work, we're pretty much up a creek. I know 5 isn't going to work because it doesn't end with a 5. No, we're just basically going to have to go to a nice little, what we did earlier, we'll take it as an approximation, about 24 and maybe 22 hundredths there, okay? Since it didn't want to break down. But that doesn't always come out perfect squares. I know a lot of times we get problems that, oh good, there were 13, but yeah, they don't always work that way. So this one was kind of a little bit off kilter. And did I get that? That's not right, is it? No, let me go back here. That's not correct. You see, you're letting me go here, right? Let's fix that. I was just saying, is it's divisible? That is not the answer, folks. I'm sorry. It's actually, let's go to this 14, and how about it? 14, and it was pretty close, but we'll call it 76 when we said hundredths there. So that is still approximate. Yeah, because I was looking at that. There's no way 24 times 24. It's getting you up there into the almost 600 range, okay? So does that work for you?
Yes.
Good? All right. And again, if you can simplify it, sometimes they ask it for radical form. That's always nice, okay? And if you take it all the way, if it's a perfect square, then you can knock it out real easily. But otherwise, I'm saying go a couple of decimal places and let it be approximate, okay? All right. Thank you for calling in this afternoon. Folks, it's that easy, all right? Just give us a call, and we will see what we can pull out of our hat and work with on you, okay? So good call right there, and a lot of things to watch out for. And I'm going to go back to that problem just a minute while we wait for whoever's going to be our next caller, hopefully coming in soon. What did we do, the steps? Let's go back through it again. We set it up. We did what here? We did a substitution, more S's. Here, we subtracted. We then squared, S. Finally, we're going to do something that doesn't have an S in it. We're going to add, down there, that's our add step. And then last but not least, we finally square root. Now the trick is, you've got to follow those steps. Your setup is fine. That was pretty easy. It's a formula. They give it to you. You substitute. That's because they gave you numbers, okay? Then you work some math, okay? Like we said, 4 minus the negative 3 got the 7. 2 minus 15 gave us that negative 3. And again, I went all over that kind of thing. Watch out. You're squaring here. They should both come out positive. That's a point where errors are made on distance problems here. So back to our caller and others who are watching and saying, oh, I'm taking note of this. Now, once we square, now we add. It is tempting. Oh my gosh, it is so tempting because you see the square root of 49. It's 7. Square root of 169. 13. And add 7 and 13 and get 20, but that's not the problem. That's not the answer. The answer tells us, or the directions here tell us in the formula, we've got to add, then square root. So do not get those out of kilter. Otherwise, there was no point in us doing the squaring part. We were just subtracted, added the results, and said move on, okay? But you got to go through that squaring process because that's what a squared plus b squared equals c squared does for you, okay? So that's your story on that, all right? So again, thank you, our caller, for that. That's a great problem, and we've done some kind of heavy math work today, haven't we? You want to do something simple for a finish up? Because we've got about a couple of minutes here. Let's do a quick division with decimals, all right? And one that'll come out even. How about this? Say I say 6 4/10, and I divide it by, how about it? 4 1/100. You say, wow, Ernie, that's kind of a crazy thing. You want me to go to the calculator? No, let's work it out. Let's work it out. These come out. This is going to come out even pretty nice there, okay? So let's put it right there. Our 4/100 on the outside, our 6 4/10 on the inside. And notice I've already added a 0 because I can do that. Yeah, I can do that. But what happens is I've got to move this decimal 2 places because that's 4 1/100ths with a th. I want to make it into a 4, all right? And if I do it here, I've got to do it out here also, all right? So you say, what's that doing for us, Ernie? That means our decimal has now moved to here, and it's now 640, and we've got a 4 here that's ready to work, all right? So let's work it. All you who are wanting easy decimals here, let's play with this, all right? It makes sense. And again, remember, whatever you move that decimal on the outside, you've got to do it on the inside. It's kind of like those same things we do equations. We have to add the same thing we add to both sides, all right? Same thing here. We've got to move that decimal the exact same way because what are we doing? We are multiplying both of these values by 100 to make things work. Now, I've babbled enough, right? Let's support the problem because we're running close on time. We got 1 times 4. How about it? I get 4. Let's bring down 2. Bring that 4 right on down. There's 24. It's 6, and that gives me 24. But my friends, we still got a 0. Bring it all down. And we need a 60 right there. 160. Decimal goes straight up, and there is your value, 160. Speaking of which, I want to take this opportunity once again to thank you all for tuning in. Also, thank you, Beard and Key Club. My goodness, I had Owie, I had Sarah, and Brayden today. Let's give them a nice round of applause. Yay, thanks, ladies, for being here from the Beard and Key Club. There they are, and they've had a good time today, and thank you for tuning in. Our caller, thank you. And also, tomorrow we have specialized segments. You're going to see a new show tomorrow, specialized segments. Friday, we're going to take Powell High School back in here and do a on the road segment. And we will see you again next time.